This question is from GATE 2012 Mechanical Engineering paper. It's question number 49. This is a common data question with question number 48 of the same year. Two steel truss members AC and BC, each having cross-sectional area of 100 millimeters square, are subjected to a horizontal force capital F as shown in the figure. All the joints are hinged. The maximum force F in kilonewton that can be applied at C such that the axial stress in any of the truss members does not exceed 100 megapascal is dash. Now this value of force in BC is being found out in this linked video, which is FBC is equal to 0.732 times F. You can refer to this video to see how we calculated the force in member BC. So this force is already known, 0.732 times of F. Now applying the vertical equilibrium equation, summation Fy equal to 0, we have vertical component of force in AC will be positive because it's upward, FAC times sine 45 degree. Vertical component in member BC is downward, so we have minus, the component here is FBC into sine 60, which is equal to 0. So FAC is nothing but FBC into sine 60 by sine 45. Let's substitute all the values. We have FAC is 0.732 F into sine 60 is root 3 by 2 divided by sine 45 is 1 by root 2. This is calculated to be 0.897 times F in kilonewton. Now we see that force in AC is greater than force in BC. So if the stress value in AC doesn't exceed the given allowable value, then in BC also it won't exceed. So we can take a force in AC to calculate value of F. Therefore, finding out stress in AC, we have stress value in member AC will be equal to force in AC divided by the area of cross section of AC. This should not exceed 100 megapascal. So force in AC should not exceed 100 into 100. This is in mm square, so we can take as it is. This one is in Newton per mm square. So force in AC in Newton should not exceed 100 into 100, that is 10,000. That is, force in AC should be less than 10,000. Let's substitute the value and find out F. Force in AC is substituted as 0.897 times F. This was in kilonewton into 1000 will give us the value in Newton, should be less than 10,000. So F should be less than 10,000 divided by 0.897 into 1000. So this comes out to be F should be less than 10 by 0.897, which is nothing but 11.15 kilonewton. It is 11.148, but we can round it off to 11.15 kilonewton. This value will be in kilonewton because we have already converted the complete force in Newton. So F will be in kilonewton directly. Let's go back and mark the correct option. So the maximum force F in kilonewton that can be applied at joint C without the stress in members exceeding 100 megapascal is option B, 11.15 kilonewton. To learn more about stresses in compression members, you can refer to the NPTEL video Introduction Strength of Materials from the course Lecture Series on Strength of Materials. This is by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope the solution will help you clear your doubt. Thank you.